no, pi over 4, sorry, pi over 4 minus by beta over 2 plus by alpha over 2. Okay. So now, how did he get this relationship? Okay. So I'm going to show you how he acquire such a relationship. Okay. So let's look at the assumption that he made, the assumptions. Okay. So in any model, you need to know what they assume. Okay. That the tool is infinitely sharp. So i.e. no cutting edge radius. Right? This is what he assumed. He assumed that so that his analysis will be simplified. Okay. Material is isotropic. So same direction, same strength in all direction. Okay. So deformation occurs in a plane. So he did not call it a zone. Okay. It's in a plane. And the assumption that he make that the cutting process is steady state. Okay, so this is what he assumed. And the friction angle beta is constant. Okay, it's constant and it's not affected by process parameters. Right? So this is an important assumption that he made. And then he also assumed that the shear angle pi, okay, the shear angle pi will orientate itself. Okay, it will orientate itself such that FP, another important thing, okay, FP will be at its minimum. Okay, minimum. Right? So i.e. this assumption that he make is known as the minimum work assumption. So now everything that we do is we want to determine this angle over here. We want to determine the shear angle. Okay, we want to determine the shear angle. So I'm going to, that circle is so messy now. Okay, I'm going to draw a smaller circle now. Okay. Okay. So I'm going to sketch a smaller circle. Okay. So the important thing is he uses FP, minimum work, right? And then we know that this is our R, resultant. And then we want to find what is our shear angle, and this is our Fs. Okay. Okay. So from here, okay, we have to relate, right? So if that's the case, we also need to know this angle over here is equal to beta minus alpha. Okay, that is our beta minus alpha. So that angle is important also. So what we want to do now, the first thing that he did, okay, what we want to find is Fs. Okay, how to relate this with Fs? So we are going to relate Fp. Okay, so what merchant want to do is, I just want to know Fp, and with Fp, I want to determine what is Fs. Okay, so we're going to relate Fp to Fs, right? Fp to Fs. Okay, so note, an important thing to note is that Fs orientation right is controlled by the shear angle. Okay, by the shear angle, right? So what is the common thing between Fp and Fs is the resultant. So Fp and Fs, right? Fp and Fs share the same, okay, same resultant force. Okay, so we're going to write an expression of Fp as a function of R, right? So we know that Fp is equal to R cos, okay, R cos beta minus alpha. This is what we know. And then the next thing we want to relate is Fs, right? So we also know that Fs is equal to cos, okay, R cos pi plus by beta minus alpha. Okay, we know this too, right? So from here, we can relate with our R, yes or no, right? So you have Fp, okay, secant beta minus alpha is equal to Fs, right? Is equal to Fs. Hey, wait, no, sorry. So R, do apologize. So we know that R, okay, I'm going to call this equation number 1 and equation number 2. From equation number 1, we know that R is equal to what? R is equal to Fp, right? Secant beta minus alpha. So this is equation 1a. So we're going to substitute 1a into equation 2 now. So we have Fs is equal to Fp secant beta minus alpha, right? Cos pi plus by beta minus alpha. This is our equation 2a because it started from equation 2, right? So we have our Fs. So in order to find the shear stress, right, we have to relate with the shear stress. Right? So the next thing that merchant did is he find the shear stress acting on the shear plane. Right? So the shear stress, which is known as tau x, is equal to Fs over As. Okay, so this is our equation number 3. Right? So to find As, so we have done this before. To find As, right, last week is equal to T width of cut over sine pi. So this is our equation number, our equation number 4. So we will substitute. Okay, we will substitute equation. We will substitute equation 2a, right, and equation 4 into equation number what? Into equation number 2. Okay, so from here, he formed another equation. Okay, he formed another equation to state that equation. So 2a and 4 is equal to equation number 3. So here have tau s is equal to, tau s is equal to Fs, which is Fp, right? Secant beta minus alpha cos phi plus by beta minus alpha, the whole thing divided by As, which is equal to T omega over psi pi, right? So what he did from here is he's going to apply, apply minimum work theory. So when we apply minimum work theory such that Fp will be what? The minimum, right? So therefore, so this is my equation of tau x, so that is my equation number 5. Right? So equation number 5 will become Fp is equal to tau s T omega or Tw over by secant beta minus alpha cos pi plus by cos pi plus by beta minus alpha and then sine pi. Okay, that is our equation number 6. So from here, what do we know? So we know that Fp needs to be at its what? We do know that Fp needs to be at its minimum. For Fp need to be its minimum, the denominator has to be at its what? Maximum. Yes or no? Right? So based on the assumption that he has made, right? This term over here is a constant. It will not change. Right? Because we state that what? Beta is a constant. If you look at the assumption, he assumed that beta is a constant, alpha is a process parameter. So there are only two things will change. So this term over here, right? This term over here, we are going to assume that we are going to find the maximum. Right? The maximum of these values over here will cause Fp to become a minimum. And he also assumed that the shear is constant. Right? He made an assumption. Okay. So he let y be equal to cos pi plus by beta minus alpha sine pi. So if you were to sketch this graph out, right? If we were to sketch this graph out, so y is the response. This is the shear angle. Okay, pi. Right? The rest are constant. Beta minus alpha are constant. So I'm just going to make a rough sketch. Right? So the maximum value is over here or over here or over here. Right? So when that happens, we know that dy over d pi must be equal to 0. Right? There's no gradient. So you differentiate dy, right? So dy over d pi is equal to cos pi plus by beta minus alpha. You differentiate cos pi, right? And then plus by sine pi plus by beta minus alpha, and this is sine pi. Okay, so when you differentiate, you got, okay, so this expression, so cos pi cos, sorry, this is minus, okay, because cos differentiate to become sine, is a minus sign over here, and this whole expression will be equal to 0. Okay, so when we rewrite the expression and when we equate the expression, because it's equal to 0, why equal to 0? Because the slope has to be equal to 0 to get the maximum what? Maximum value, right? So from here, we will have this expression where cos pi plus by beta minus alpha cos pi, this equals sine pi plus by beta minus alpha sine pi. Okay. Then we shift things around. So we have cotangent pi is equal to tangent pi plus by tangent pi plus by beta minus alpha, right? So we also why am I yeah? So we also know that this is tangent is equal to, so there's a phase shift, right? Pi over 2 minus by the shear angle. This is equal to tangent pi plus by beta minus alpha. So this expression can be pi over 2 minus shear angle pi plus by beta minus alpha, right? So from here, we can rewrite that pi over 2 minus beta plus by alpha is equal to 2 of the shear angle. The shear angle will be equal to pi over 4 minus beta over 2 plus by alpha over 2. So that's how he derived the shear angle relationship. Okay, so this is the expression that he has got to derive the shear angle. Why he did that is because he don't want to measure the deformed chip thickness. He just wants to use this expression. On that note, okay, this is the end of lecture. Okay, and before I end, I know this has not been easy for you all. Okay, and thank you for spending time with me. 13 weeks. Okay, and I hope to see you one good day. Okay. On that note, I end my lecture now. So our final exam will be up to here. So anything after term test 2, up to here is where we have our final exam. Thank you so much. And I'm not going to lock out yet. I'll still be here. If you all have any question, okay, you all can